Here, the location of the present-day capital of Algeria, Alger, and Tipaza, which is in a complicated tectonic setting with basement, volcanic rock, the pre-Neogene Mitidja Basin, Sahel anticline, and in connection with the rotation of Africa plate since 80 million years, you have a high mobility, high tectonic mobility. So we have work between Tipaza and Delis, but I will present you in archaeological context, mainly our research from Tipaza. So first of all, we have discovered, like in the southern of France, like in Italy, Roman quarries that are about 0.5 meter below present sea level, which was not in Algeria studied by Pirazzoli, but was mentioned by Pirazzoli, and it was in connection to his paper published in Science in 74, so 50 years ago. And these quarries, submerged quarry, are recovered by megablocks and mesoblocks and some elements of the necropolis, of the late Roman necropolis. It's a paleo mushroom rook with a notch, and this have been reworked by waves and coastal energy. So yes, the landscape of Tipaza is quite impressive with these domino style mega blocks coming from mesoblocks, mega blocks coming from the infratidal zone, from the marine area, recovered by marine organism, some with pools, with Kamenitsa coming from the mid or the lower tidal zone, with paleonotch or micromorphological indice of the proximity of the shore, or even some megablocks coming from the supratidal zone, so 1-2 meters above the present day. This is a mix, and you can follow this type of ridge for kilometers east of Tipaza. On the far east, you can see the yellow buildings of the suburb of Alger. So yes, when you see this type of landscape, you can be interested in the archaeological records, but you can also be interested to think about the present-day vulnerability of a million inhabitant city like Alger facing the Algerian basin. So these are some of the mesoblocks that Said is inspecting. I must confess that I forgot the size and the estimated tones, but you can find this easily in our paper. And these are the incrustation that we found of some blocks. I must also say that most of the big blocks were void of serpulids or Kama or Austria. So the bigger blocks was not possible to date. First point of uncertainty. Second point of uncertainty, date these animals, it's complicated because you are all aware of the question of reservoir effect, and we are not sure that the reservoir age of this part of the Algerian Sea is close to the 400 years. So the correction is probably a little bit different. So there is a second imprecision. In some blocks, we have been able to extract some very fresh lithophaga shells. You can see also marine algae, red algae incrustation. You can see cupula Erkins. So there is plenty of connection between the micromorphology and the biological indicators. Here you can see a very nice image because we are on the supratidal zone, even on the tidal zone, and you can see that the stratigraphy of this Pleistocene ridge with Ramla rock and clay, interbedded clay lamina, it's a good extraction zone for the waves, 3-4 meters above the present sea, and the accumulation landward. So if I can conclude on this second case study, most of the radiocarbon dates gave us some chronology in connection with the Little Ice Age between the 14th century and the 19th century. So we are absolutely sure we have a seismological activity inland and offshore, but most of our blocks, the Mesoblocks, are connected to storm events in connection to Little Ice Age. Let's move to the third and final case study. Jenny Capi, the PhD of Bonny, and we published a first paper 10 years ago. So Jenny Capi is the Theodos Harbour in Constantinopolis. It was founded during the late 4th century AD. It's facing the Sea of Marmara, and it's inside what we call the wall of Constantine, and of course inside the wall of Theodosius too. So the location of Istanbul is very problematic in terms of vulnerability, because Istanbul is constructed above the North Anatolian fault or faulting zone. So the high seismicity is very problematic, and a few years ago you have a huge earthquake destroying a lot of buildings and killing a lot of people, not due to the tectonic shock, but due to the bad construction process in order to avoid too many destruction during earthquake. This is a nice image that was given by Dogan Perinçek, our Turkish colleagues. And you can see 3 units from base to top. At the base, you have a fine sediments, fine sands, which attest of a calm environment. It's the harbor environment, typical setting with, from place to place, some artifacts, because the harbor is a dump. You have on the middle zone a second layer, which is totally chaotic, very coarse, very heterogeneous in terms of color, in terms of content, with blocks, rounded pebbles, with angular blocks, with ceramics, mainly from the 5th to 7th century AD, bones and material coming from the marine environment offshore and material coming from the land. And you have a third unit, which is post 7th century AD, 8th, 9th century AD, which is very similar to the first one. So it's the cicatrization of the harbor after the catastrophe, and you have a calm setting, calm artificial protecting setting for harbor's function. This is the top of Unit 4. You can see it's like a paving. It's what we call in archaeology a destruction layer. So with Genaël Bonny, Genaël work on the macrofauna assemblages on the section of the Unit 4, on the foraminifera assemblages, so unicellular, and from the ostracoda assemblages. So 3 different biological indicators, and the conclusion of his very careful work was that Unit 4, corresponding to the 4th and 5th century AD, interpreted by the archaeologist and the geologist by a tsunami deposit, is a real mixture of marine, coastal, and lagunal environment with some freshwater environment input and continental material, characteristic of a high energy event. So, okay, with this type of good quality record, we can publish and we can interpret this unit as a possible tsunami impact, corresponding, if we look at the different catalogs, to possible 447 or 477 480 or 553 or 557 AD. After it's a question of selection and close correlation with the destruction of the archaeological record. We choose with our colleague to interpret this deposit corresponding to the late 6th century AD in connection with archaeologists. But there is many unsolved questions because we have an excellent catalogue, because Constantinople, Istanbul, was the capital of the Ottoman power. So you have a lot of interesting historians focusing on this tsunami or heavy storm or important storm. For example, Yalciner published a catalogue of 30 tsunami. Altinok published of 40 tsunami facing the Marmara shore in the last 2,000 years. So the question is that during the Yenikapı excavation, we were able to discriminate 2 high energy deposits. And here you can see that there is probably at least 40 tsunami deposits that have possibly affected the Theodosius Harbor. So where are the other ones? So there is a real problem of scientific demonstration. Okay, one element can be the question of the dredging of the harbor. So maybe in order to find good deposits of tsunami deposit, we have mainly to work outside the harbor basin. But it's really problematic, this unsolved question of the number of tsunami deposits in the catalogue and the absence of high energy deposits on the stratigraphic record. So in order to, not to complete completely, but to try to synthesize this work, which is not the main topic of my research, with Mariner, we were trying to work on lexicology, and we have used the Scopus Earth and Planetary Science record and catalog with different keywords like disaster, earthquake. Let's have a look to the word tsunami, for example. It's what I was saying in introduction. You can see that really the rise of the use or even abuse of the term of tsunami is post-tsunami of 2004 and Sumatra. Before 20 years, there were almost no geologists working on tsunamis, except if you were in a geology in Hawaii, in Japan, or along the fire belt of the Pacific, Peru to Alaska. But it was very small session inside very important, very big geological international venue, like the American Geophysical Union meeting. And after 2004, it begins really very trendy, this tsunami interpretation. Why? What are the possible explanations about the use and abuse of neocatastrophic interpretation and finally, in most of the time, factoids? So I'm not a psychologist, but I must confess that there is certainly, in connection with the present organization of science, the impact factor race, and it's certainly more easy to publish a tsunami than a normal storm. There is also the media race opportunism, and I'm convinced this can play an important role. A second element, maybe more scientific, is the base of geology. As you all know, geology is by definition the science of discontinuity, because geology was invented by the German scholar during the revolution, the Industrial Revolution, because it was mining geology. So there is plenty of faults. So you have to face with this discontinuous stratigraphy. So all the elements of the classical geology are discontinuity, and all the elements